Alright, okay, we're going to start off with a velocity time graph, which is initially what every single SUVAT equation starts with. And it starts from a point above zero, which is the initial velocity, and it is a graph of velocity by time. End velocity is at the end of the graph. So the first one we're going to start off with is v take away u over t is equal to a. This is the formula for the gradient, as the change in y is v take away u, and the change in x is t take away 0, which is essentially t. Then we have this equation. Now we can rearrange this to get v take away u is equal to at, and then we're left with v is equal to u plus at. That's the first equation done. We can tick that off. Gosh. Now we have the second equation. We're going to be using the graph again, and we're going to get the area. The area underneath the graph to the graph line is the displacement, S. So we have the area of a trapezium, which is half a plus b h, or you could write a plus b over 2h. Now we're going to use the same concept but with velocity and time. Now we have u plus v plus u over 2 t is equal to s. That is the second equation. Now we're going to write them down for reference. V is equal to u plus at, s is equal to u v plus u over 2t. Now to find the third equation, we are going to be removing the t from v is equal to u plus at by rearranging the second formula for t. To do that, we will be first rearranging this. 2s is equal to v plus u t, and then it ends up with 2s over v plus u is equal to t. Now we're going to be placing that into the other formula. V is equal to u plus a plus 2as, so 2s times by a, over v plus u. Now we're going to rearrange this, v squared, and we end up with v squared is equal to u squared plus 2as. That is the third formula. And we've finished that. Now we're going to move on to the fourth one, which requires a similar process. Instead, we are going to be rearranging this formula here for the area by replacing the v and then replacing the u. So we're left with a formula without them. So our v is equal to u plus at, v s is equal to v plus u over 2t, and we are going to rearrange this one. But we don't need to for the first one because it's already equal to v. S is equal to u plus at, put another brackets, plus u over 2 times by t. Now we're going to rearrange this and we'll be left with the formula. Firstly, we're going to add the two u's, so we're left with s is equal to 2u plus at over 2t. Then we can divide by 2, so we're left with s is equal to u plus half at times by t then we can finally expand the brackets, and we're left with s is equal to ut plus half at squared. Next one we're going to do is rearrange this formula for u. So we're left with u is equal to v take away at. Now we're going to substitute this formula into s is equal to v plus u over 2t to get this. S is equal to v plus v take away a t over 2 t. Now we're going to do the exact same thing we did over here, and first we're going to add the v's. 2v take away at over 2t. S is equal to v take away half at times by t, which we're then left with v take away half at squared. Now we can prove these two formulas with a graph, or use a different pen so it stands out more. Firstly, we're going to start off with the graph for s is equal to ut plus half at squared. Okay, that is what essentially we're going to get. We have t. Now we're going to label out the area underneath the graph to the graph line by two separate parts. We have area A and we have area B. Area A, oh gosh, I used a pen for it. Area A is equal to v take away u over 2 times by t. And this is because we are dividing by 2 because it's a triangle. And to find the length, it's v take away the initial velocity and then timesing it by t. Now remembering back to the original equation that we got, v is equal to u plus at, we can rearrange to get v take away u is equal to at, and we can substitute that into this equation. So then we're left with at over 2 times by t, which leaves us with half at squared for the area of A. Then for the area of B, it's just ut. So then we can add A plus B, and we're left with ut plus half at squared is equal to s. Then we can do the same thing for the other one, where we essentially use the same graph and instead of splitting it up the way that we did, we're going to use the whole area as A, and the top area, the area above the line, as B. That's fine, I'll just use the same color. A in this circumstance or time is equal to VT, as it's the whole area. B, however, is equal to v take away u over 2 again is a triangle times by t. Now this time we're going to use the whole area, so area A take away area B to find the area underneath the line, which is equal to VT, and as you remember before, this simplifies to half AT squared due to V take away U is equal to AT. And so we're left with A take away B is equal to S equaling VT take away half AT squared. And that's essentially it for all of the different equations. So we're finally left with V is equal to U plus AT for the gradient. From the gradient, we got S is equal to V plus U over 2T from the area under. To substitute out the T from the first equation, we ended up with V squared is equal to U squared plus 2AS. To remove the V, we ended up S is equal to UT plus half AT squared. To remove the U, we ended up with S is equal to VT minus half AT squared. And that's it.